Now, geometrically, we're going to represent the vector 1, 4 by an arrow that moves over 1 unit in the x direction and 1, 2, 3, 4 units in the y direction. Now we start the arrow at the origin and we end it at the point 1, 4. And that arrow represents the vector 1, 4. Okay. And then we also want to represent the vector 2, 8. So we come over 2 units and we come up 8 units. We've got a point here and we come back to the origin. Oh, I want to write it. As a column vector. Okay? So we have the vector 2, 4 here, the vector 1, 4, I'm sorry, and the vector 2, 8 here. Now we want to be able to add those vectors in order to get the vector 4, 24. Now where's the vector 4, 24? Well, unfortunately, I chose a bad, big set of numbers. 4 would be over here, and 24 would be 3 times this high, so 424 would be up here somewhere. And it would be straight, and that thing's kind of curved and sway back. Okay, so this is the vector. Don't have a good place to label it. 4, 24. Well, to add 2 vectors, we put them head to tail. Okay, so I could take this vector here and move its original point. We call the origin in this case would be the initial point of each vector. Okay, now we can move vectors around, so I can move this vector here so that its initial point coincides with the terminal point of this vector. Okay, so I can move the blue vector up here, and I would get a vector starting at the origin, ending wherever that blue vector ends, that would be equal to the sum of these 2 vectors. Now, if you think about it, adding multiples of these 2 vectors, this vector has a second component 4 times the first. The same is true of this vector. Anything I can get by adding multiples of these vectors is going to have its second component. The second number is going to be 4 times the first. Okay? This vector, second number is 6 times the first. It's not going to work. Okay? So, we can't really tell that by looking at the picture, but any sum of these 2 vectors, if they start at the origin, is going to go from 2 points where the rise is 4 times the run, essentially. The rise of this vector is 6 times the run, and we just can't do it. Okay, in general, if we have a vector like this, and a vector like this, and another vector like this, it can be done. Okay, in this case, we would just take a multiple of this vector, which means that we can start here and move in the direction of this vector as far as we want. So let's see, this vector kind of goes along this line. Okay, a vector that's equal to double this vector would be out here, triple the vector would be out here. 1.7 times the vector, well, it'd be the length of the vector, a little less than 2, be out here. this vector is in this direction. Okay? Now, there is some multiple of this vector, if I've got the directions right, that's equal to this. Okay? And there's a multiple of this vector that's equal to this. So that this vector would be, let's say, C1V1, and this vector would be C2V2, and if this vector is W, then we would have C1V1 added to C2V2 equals W. So if the vectors are like this, we can do it. But if the vectors both go in the same direction, we can never get off the line of either one. If we start at the same point that the W vector starts, we're stuck in one direction, and if that direction doesn't coincide with the direction of W, we can't get there. Now, if you're seeing this after having puzzled over vectors for a while, it'll should make a good bit of sense to you. If you haven't puzzled over vectors by much, you're thinking right now will probably be something like, huh? But if we haven't done this, we're going to do it very soon. We're going to do it in more detail, and we'll see exactly what it means.